In this first lesson, we're going to be looking at transformations of quadratic functions. Now, most of this lesson, or at least a good chunk of this lesson, will be a review from last year. However, I know it's been a little while, so here we go. Let's get started. We're going to look at understanding the roles of the a, the h, and the k in the equation y equals a times bracket x plus h bracket squared plus k. And then we're going to describe how the graph of y equals x squared is transformed in order to make this other equation. But before we begin that, it would probably be good if we reviewed how do you graph y equals x squared and what exactly does it look like? Well, y equals x squared is, the graph of it is called a parabola, and this type of equation is called a quadratic. Notice it has this degree of 2, this 2 exponent. Remember from before, y equals mx plus b, and that's a linear equation. This will look like a straight line of some sort, whereas y equals x squared looks something more like a U shape. Okay, so we're not talking about something that looks like a straight line. But what does this graph exactly look like? How can I put it on the grid? Well, there's a couple ways we could do it. One way would be a table of values. So we can set up a table of values, and we've got our x and we've got our y, and we can pick some x's from -2 up to +2, for example. And then we're just going to plug each of these x's into our equation, which is y equals x squared. So y, the y value, is just whatever the x value is squared. So -2 squared is -2 times -2, which is +4. So this is the first dot that we can put on our grid that is part of this parabola. So -2, 4, we know that this point right here is on the parabola. Now -1 squared is +1. So -1, 1, -1, 1. There's another dot for us. 0 times 0 is 0. So 0, 0 is on our parabola. 1 squared is 1. So we can go to 1, 1. And 2, 2 squared is 4. So 2, 4. There's another dot on the parabola. And we could pick other values as well. But here's one way that we can figure out, there's one way we can figure out what the equation would look like, what the graph would look like for this parabola. So it would come up here through this dot, and also come down here through these dots. And here is my semi-messy parabola. Now there's one way we can do it. If you memorize these notes, that's another way these coordinates, that's another way we could do it. A third way would just be taking the numbers 1, 3, 5, and 7. And if there's no number in front of the x squared, so there's no like 3 here or -6 or anything like that, then we start at 0, 0. So to graph y equals x squared, we just start at 0, 0, and then we go over 1, up 1. So over 1, up 1. Put a dot there. Then we go over 1, up 3. So over 1, up 3 more. 1, 2, 3. And the next point would be over 1 from there and up 5 more. So over 1, up 5 more. 1, 2, 3, 4, 5. We'd be up here at 9. And the next one would be over 1 and up another 7 from there. And that's going to take us off the screen. Notice that parabolas are symmetrical, so we can just put these points over on the other side, just like that. And we can continue on the graph if we would like to, like this. Okay, so this is what y equals x squared looks like. This is sort of like our base function, and all of our other parabolas will be this guy, but changed somehow. So what does a do? And remember, our equation is y equals a bracket x plus h squared plus k. So what does this part of the equation do? Well, the a tells us whether the parabola will be opening up or opening down. Now here we've got a parabola that we say is opening up. So it's like a cup kind of. So it's opening upward, whereas this parabola is opening down. So a parabola will be opening up if the value of a is bigger than 0. In other words, if a is positive. An example would be like y equals 3x squared. Here's a parabola where the number in front of the x squared is a positive number. Now the one we graphed last time, which was just y equals x squared, there's no number right here that you can see, which really means there's just a 1 there. 1 is positive, so that parabola is opening up. Now in this case, where the parabola is opening downward, that means that the value of a is less than 0, or it's a negative number. An example would be y equals negative 2x squared. Now this equation isn't for this graph, just like this equation isn't for this graph. These are just some equations that work for telling you whether a parabola opens up or down. So here we've got two equations right here, and we're wondering, do these parabolas open up or down? Well, for this first one, we first need to figure out which one is a. Now remember, the general equation is y equals a x plus h squared plus k. And a is always the number that's either right in front of the x squared if there's no brackets, or the number that's right in front of the brackets if there are. Now here we've got some brackets, and that means that our value of a is negative 2. Here's our a. So if a is negative 2, a is less than 0, so our parabola must be opening down. So it opens down. Now for the second example, there is no a that you can see at least, right? There's no number right here in front of the brackets. So what is the value of a? Well, when there's nothing shown, it's just 1. 1 times anything is itself, so there's an imaginary 1 right here. Or I should say invisible 1, it's not imaginary. So this parabola, is it opening up or down? Well, since a is bigger than 0, a is a positive number, this parabola must open up. So this parabola right here, it would be shaped somewhat like this, and this parabola would be shaped like this. So now we get to the part of h. What is the h doing? And again, the general equation, y equals a x plus h squared plus k. Now in the book they have a minus here. I find that a little bit more confusing, I think, but you can read the book if you'd like and go with what the book says. I'm using a positive here. Now the equation for this parabola right here is actually y equals x minus 2 squared. And the equation for the red one is just our base parabola, which is y equals x squared. Okay, so what's happening to this parabola? Let's move this. What's happening to this parabola? Well, we've got our basic y equals x squared, and that's our starting position. And you can see this blue one, which is y equals x minus 2 squared, is actually shifted exactly 2 units to the right. So you can see this point right here is shifted exactly 2 units over, straight to the right. Just like this part right here, which is called the vertex, that part is shifted exactly 2 units to the right. And if we were to look at every single coordinate, so here's another one, if we were to look at every single coordinate, we'd see 1, 2, it's shifted exactly 2 units to the right. And we've got this x minus 2 squared. So we could say that h is equal to 2, h is equal to negative 2. And what's happening there? Well, we're shifting 2 to the right. So whatever number's inside the brackets with the x, inside the brackets with that squared out here, that number is going to tell you how far you're going to go left or right. Now, it's kind of backwards from what you'd expect. If it's negative, we're going to the right. And if it's positive, we'll be going to the left. And here's a couple examples. We're wondering, what is the value of h for each of these? And how is the parabola transformed? Well, for this first one, we would say that h is negative 3. Okay, that's the number that's inside the brackets with the x. And that means we are shifting our parabola 3. Now, is it to the right or to the left? Well, when it's at -3, we would think it would be to the left, but it's actually to the right, just like in our previous example. So it's 3 to the right. Now for this one, we've got three numbers here. We've got this -5, this +2, and this -1. H is going to be the one that's inside the brackets with the x. So our H is the +2, which means our parabola is going to be shifted 2 to the left. So if H is +2, we're going 2 to the left. Again, for H, it's the opposite of what you expect. When it's negative, you expect it to go to the left, but it goes to the right. When it's positive, you expect it to go to the right, but it goes to the left. Okay, now what does the value of k do? I'll write down our general equation, y equals a x plus h squared plus k. Remember, a tells you if it's opening up or down, h tells you moving left or right, k then is telling you whether you're moving up or down. All right, so here we've got two parabolas. Again, our red one here is just our basic y equals x squared. Okay, I've just graphed that for you. And the blue one, this equation is actually y equals x squared plus 2. Okay, so what's happening here? Well, the k, the number that's on the end, it's always after the squared part. So after your exponent, the number that's on the end. In this case, our k is 2. And you can see all of these points have been shifted up exactly 2 units. So if we found another one, here's another one. If we look straight up, it should be exactly 2 units directly above where it was before. So k shifts our parabola up or down. Now, unlike the h where it's kind of opposite of what you expect, k works exactly how you'd expect. If you add 2 on the end, it's going to go 2 up. If you subtract 2 from the end, we're going to go 2 down. Now here's a couple of examples. What's the value of k for each of them, and how does it transform the parabola? Well, for this first one, our k is +9. Again, it's the number that's on the end after the squared, after the exponent. So what's happening here? Well, we're simply shifting our parabola 9 up. Okay, we've got this one. What's the value of k here? Well, k is -3. Again, it's the number that's after the squared. It's the number on the end. And if k is -3, we're shifting our parabola 3 down. So the shape hasn't changed at all. We're just shifting every single point 3 downward. Now, in this example, it says describe the transformations on y equals x squared to get y equals -x minus 2 squared plus 4. So we're going to have to look at this, break it up into 3 parts. We've got this first part right here, the second part, and this third part. Now remember, our general equation is y equals a x plus h squared plus k. So we can see that a must be this number right here. Now if we just have a minus sign, it really means -1. H must be -2. And finally, k must be the number on the end after the exponent, which is +4. Now, what 3 things are happening here? Well, when a is -1, we know that our parabola is going to open down. When h is -2, our parabola is shifting left or right, because that's what h is controlling. So if our parabola is shifting left or right, remember if h is negative, you would think it would go left, but it actually goes to the right. So we're actually going 2 to the right. And finally, when k is 4, we're going to shift it 4 up. And we need to do all 3 of these things. Okay? Now I'll show you how this works. First, we need to put on our original parabola. Okay, so hopefully you remember, you can go go back in this video if you can't remember how to graph it, but 0, 0, 1, 1, 2, 4, and 3, 9. And since it's symmetrical, we've got all these points exactly on the opposite side of the y-axis. Here is our original parabola, and we can connect the dots, make it look nice and smooth through there as best as we can. And we've got dots over here on this side too that we can connect. So we'll come down like this, down like that. Here's our original parabola. Now, these in-between points, since they're not nicely on the grid, I'm not going to worry about them too much. I'm just concerned with these dots and what's going to happen to each of those using these three transformations. So first of all, when a is -1, it means we're opening down. So what does that mean? It means we're actually flipping over this x-axis. So instead of the parabola being up, it's going to be down like this. Now I don't have enough space here to graph every single one of these points, but if we were to flip this point over the x-axis, well, it's already on the x-axis. So this point right here is, when it flips over, is going to stay right there. Whereas this point right here, you can see it's 1 up, so instead it's going to be 1 down. We need to flip it as if this x-axis is a mirror right here. Now the same thing's going to happen for this point. It's going to flip down, so it's right here. Now with the next one, we can't get it on there because the grid has run out. At the bottom you can see, but instead of being 4 up, it's going to be 4 down. It's going to be down here somewhere, 4 down. Same thing with this guy over here. He's going to be 4 below the x-axis because he was 4 above. This point is 9 above. Well, now he's going to be 9 below the x-axis. So every point has gotten flipped over, and you can see our parabola is a mirror image that's opening downward. Now what's going to happen with the h and the k? Well, the h is going to shift all of those points 2 to the right, and the k is going to shift them all 4 up. So let's look at this original point. Okay, so it got flipped down. It's still where it is. We need to go 2 to the right, 1, 2, and 4 up. 1, 2, 3, 4. So our original point right here got flipped over, 2 to the right, and 4 up. This point got flipped over. Now it has to go 2 to the right, 1, 2, and it has to go 4 up. 1, 2, 3, 4. Okay, so we've got this point now, and we've got this one. Let's put this one on. So it got flipped over. It's got to go 2 to the right, and 1, 2, 3, 4 up. Okay, now this one we couldn't see, but remember, since it's up here at 4, if we flip it over, it's down at -4. Okay, so it's down here at -4. It's got to go 2 to the right. So it was on this -2 line. 2 to the right would put us on the y-axis, and it's got to go 4 up. So since it's going 4 up from down here at -4, we'll end up back at the x-axis. And notice that these points are kind of symmetrical, right? So wherever your middle of your parabola is, which is sort of like this is the middle line of our parabola, we have the exact same shape that we did before. It's just that it got flipped over, and then it got shifted to the right, and then it got shifted up. So you can see this point's here. It's 1 over and 3 more down. So we've got 1 over and 3 more down to make it symmetrical. And those are all of the points that we can fit for our parabola. So this red parabola is actually y equals -x minus 2 squared plus 4. We took our original graph, we took the points, we flipped it over the x-axis, we moved all of those points 2 to the right, and then we moved them all 4 up, and this is what we ended up with right here. Okay, and that is the end of the lesson.